We've got a lot to get through today, so let's get straight in and say big thanks to my wonderful members and patrons. I want to give massive thanks to all of my supporting members and patrons. Thank you all so very much. So Kyle had done a MAGE debunk video and I issued a MAGE Rage response. Well, Kyle has taken that response on board and he's come back with a further response. Kyle had done a very respectful response and I think you'll see that this one is too, and it's very interesting. So I want to give it a fair crack. So let's go with this then, and we'll have a look at Kyle's response. Take it away, Kyle.
Last time, we asked Mr. Sensible why he decided to name his balloon satellite MAGE. It turns out he was able to answer that for us.
When I think of mages, I think of wizards, magicians, and magic tricks. The dictionary definition of mage is a magician, after all.
It is in some dictionaries, in others, it's a magician or a learned person. It's just fun. It is an acronym. Don't get hung up on it. It's nothing to do with magic. Okay?
He named it MAGE because mage meant a learned person?
Kyle, I did say don't get hung up on it. No, I didn't name it MAGE because it meant a learned person. I brainstormed and thought of all words like sphere, globe, orbit and whatever to try and make a nice, simple, short acronym. And I came up with Mission Above Globe Earth, which happens to be MAGE, which does mean a magician, but it also means a learned person. But that's not why I chose it. There we go. Look, it doesn't matter. I could have called it cheese. I could have called it football. I could have called it anything. It doesn't matter. So let's just move on.
Now, I should also mention here that Mr. Sensible doesn't consider his device to be a balloon satellite.
Because it's not a balloon satellite. And I'm assuming it's a slip of the tongue. It's not a satellite, it is a balloon. A satellite is something different. But okay, let's carry on.
I certainly think it resembles a balloon satellite. This makes me really wonder how he distinguishes the two from each other.
That image you've got there is a balloon with a payload that looks like your traditional satellite. If I quickly show you this, these are balloon satellites. With a balloon satellite, it's taken up into orbit. If the image actually comes up, it's taken up into orbit and then it is inflated. What we have with MAGE is a balloon.
Alright, so in my last video I took 5 screenshots from his uncut MAGE footage and carefully analyzed them. Please allow me to share his responses with you. We'll start with his responses to that first picture at 3,000 meters.
Well, yes, that is pretty much slap bang in the middle, thank you. But 3,300 meters is not high enough to show the curve. Not high enough at all. Which is why when we come to results, I didn't use any heights as low as that, but okay.
Here I have taken a straight line across the horizon, and it looks pretty flat. Let's take another shot from a higher altitude and see if that changes.
Oh, okay, I take back what I said. That's fair enough, you're just doing comparison. Carry on.
Hooray! Mr. Sensible appeared to acknowledge that this horizon appears flat.
Yes, I did, because any curvature is going to be very hard to see at that sort of height. And of course, I fully acknowledge things where they're the case.
Ooh, just a little over 11,000 meters now. Let's put a straight line across that. Alright, so as I drag the line across the horizon, I see that the atmospheric gradient is so strong, it is difficult to see where I should put the other end of the line.
Absolutely, which is why even at maximum height, it was actually quite difficult to find shots that you could have any clue, sort of sharp edge clue to draw lines to, because a lot of it is blurry, which makes things very difficult, and you've obviously acknowledged that. My goodness, we're doing well so far, mate.
Let's adjust the brightness and contrast of this picture to see if that can't sharpen the image and make things easier. I don't even have to draw a straight line across this. I fully acknowledge that I can see some curvature.
Wow. Thank you, Kyle. You're right. It's absolutely obviously some curvature. Whatever the cause, there is curvature, which makes a massive change from a lot of those flat earthers who are just denying it and saying, no, that looks straight to me. He's right. Thank you for that.
Wow, he is celebrating our common ground here as well.
Celebrating common ground, or just decently acknowledging honesty on your part? That's all it was, but thanks, Carl.
This makes him really fun to talk to.
Now my question is this the curvature of the Earth that we are looking at? Well,
I'm not really sure what else it can be. Let's give it a crack.
What I'm going to look for now is if this is the curvature of the Earth that we are looking at. I expect it to have about the same amount of curvature all the way across.
Before you look at that though, Kyle, it surely either has to be one of two things. The curve of the Earth or distortion. Look at the line. There's the upper line there. There's the lower line there. How could something that's straight, flat, in between those be curving more than either of those lines? Good point. Remember that barrel distortion chart. Across the middle is where you're going to get no distortion. So why is it curved? Let's just let you carry on.
Well, my question is the center of those two lines the center of the lens?
Probably not exactly. The center of the lens will be the center of the image. It's fairly close. All you got to do is be somewhere near the middle. If you want an exact center, then count the pixels and you'll get the exact center. The two lines are roughly a third up and a third down. That's all.
Just having two digital straight lines,
not digital, physical. Those are physical strings.
Running across your HUD doesn't prove anything about where the center of your lens actually is.
No, but it provides you with a reference. It provides you with two straight lines to compare the horizon to. And as you have acknowledged, quite honestly and quite fairly, and I gratefully received that acknowledgement, the horizon appears curved.
He could just be zooming in on his actual video.
Oh no, I couldn't, Kyle. I have the full raw footage. You'll find it matches up across the several videos I've done, and if push came to shove, I can give you a chunk of that video and you will see that it's not zoomed in at all, okay?
And only be showing us the bottom half of his video.
That would be naughty.
But let's continue on under the assumption that he is not doing anything underhanded here.
Thank you, Carl. And just for the record, no, I'm not doing anything underhanded.
And that this is actually the center of his lens. With that, I agree that this probably isn't lens distortion. I want to mention here that if he did fudge the footage, he already knows it's flat, and there was no point in arguing with him.
Well, if I had fudged the footage and was shown to have fudged the footage, that would show that I've been dishonest, obviously, and I should be called out on that big time. So if you wish to have sort of absolute proof, I'll find the segment of video at, 11,000 meters roughly, and I will send you a chunk of that video. You will see that it matches up, okay?
But if he didn't fudge the footage, then I think there's value in continuing on with this.
Yes.
And I really do think he's sincere about this.
I am.
So I'll continue on.
Thank you.
If the right side curves faster than the left side, that is where we're going to bump into some problems.
Are we?
Let's do MC Toon's scrunched horizon trick to check out the curvature of this. Alright, here I'm going to go ahead and select all of that, and then we're going to scrunch it really quick. Select. And scrunch.
Oh dear.
Yeah, that right side definitely doesn't have the same amount of curvature as the left side does.
But have you noticed that straight yellow line, although the angle has changed, remains straight?
Yes,
and
it does.
I'm not quite sure why you have a problem with the amount of curve there to there. Remember this straight line, the angle has changed. So you think with a curve, the angle's changing all the time. When you scrunch it, you're changing it again.
Listen to him.
More on that in a while.
I'm sure.
And another interesting thing to observe is the center of our curve isn't the center of our photo. I wonder why that is.
I understand Mr. Sensible's camera was rocking back and forth and wasn't always level, so let's rotate this and level it out. If that's the curvature of the Earth, that looks pretty lopsided to me.
Let's try this again.
Well, as I had discussed in that video, it depends on the angle of the photo and which direction you're scrunching it, and that curve will be distorted differently according to the angle of the curve. So having scrunched it and distorted it, you can't just rotate the image. It doesn't work. And you could do that with a football or something.
Just over 15,000 meters.
Very blurry image there though, Kyle. I would hope that there's some better ones that you could have picked.
Okay, let's adjust that brightness and contrast. And we'll check to see if our line is where it's supposed to be. Okay. I do see some curvature there.
Good.
Good.
Let's go ahead and scrunch that and do our scrunched horizon trick. Look for the same thing. Scrunch. Huh. Well, that's interesting.
Is it?
We don't see the same amount of curvature as we did in the last picture.
It depends on what you're looking at.
That right side looks a lot flatter than it used to. What's going on here?
I think, with all due respect, Carl, what's going on is you're not quite understanding what happens when you scrunch the picture.
Quite right, Mr. S.
And I demonstrated that. And I think that Carl is going to respond to that shortly. Left to right. Scrunch.
So here at 15,000 meters, Mr. Sensible doesn't appear to acknowledge how the horizon appears half curved and half straight. He just said he doesn't think I understand what happens when I scrunch the picture. I've got to mention here how on my debate board, the argument "you don't understand" has been ruled out as a dead argument.
Well, it's not an argument, it's just a statement. And it signifies you need to look into something a bit more. Okay? It's not an insult. It is saying that you're obviously not understanding something, whether it's that I've not explained it or whatever.
When a person makes that claim, they imply that they know more about the subject than their opponent does.
Well, if I was talking to a nuclear engineer and I explained to the nuclear engineer how much cheese he needed to put into that nuclear reactor, and he said, you don't understand, you don't put cheese in nuclear reactors, you put in plutonium or whatever, he would be right. It'd be an error on my part because I didn't understand how nuclear reactors work. So that's not a fallacy. He would be stating a fact.
And that makes them right. Just because someone doesn't understand something doesn't mean their claim is wrong.
No, quite right. It could be that nuclear reactors do rely on cheese, and in fact, the nuclear scientist I was speaking to perhaps only worked with a certain aspect of nuclear reactors, and cheese comes in at a different point in the whole system. So the fact that he knows more about nuclear reactors than me wouldn't mean that I was necessarily wrong. However, it would mean, if he's a nuclear scientist, it would mean that I should actually think, maybe he's correct. Maybe I should do some more research on the aspects of cheese use in nuclear reactors.
And just because someone knows more about something than someone else, that doesn't mean their claim is right.
Correct.
This falls in line with the genetic fallacy because it's judging a claim to be right or wrong based on the person who made the claim.
Yeah, I wasn't judging anything based on you. I was saying that you were wrong because you really did not seem to understand at that time how scrunching an image with a curve in it will not give you a nice even curve after the scrunch. That's all.
It also falls in line with the ad hominem fallacy. Rather than explaining how or why a person is wrong, they're just attacking a person rather than their argument.
But I wasn't attacking you. I was saying that you were wrong, and actually then I did explain, didn't I? So it wasn't just an ad hominem.
Herein, they're just throwing insults, which is counterproductive.
Alright, let's go even higher. 25,000 meters. Will it get flatter or will it get more curved? Alright, brightness and contrast. Check in our line to make sure it's accurate.
I'm just going to pause you a second there. No fault of your own, but over here, just due to the colours of the shadow of clouds and non-clouds and so on, you've got the horizon line. I'll call it a line, not straight, not curved, but you've got that horizon there, which gets cut off purely because of the background colours. So you've not really got a full width to play with, but you know, that's not your fault.
Alright, let's do the scrunched horizon part.
Let's. Oh, okay, you've just taken that part. Fair enough. See, I quite happily acknowledge that you were not doing anything underhand there, Kyle.
Scrunch! I think it's interesting how Mr. Sensible is 100% convinced that this proves the Earth is a globe.
Well, what you've got to remember, Kyle, is that camera is a narrow angle camera. We have got a narrow field of view, so you're not going to see much curve. Then, in this case, we're actually using less of it. So I would have to say, probably best to use a different image.
I would have to.
I'm not saying you've done anything underhand.
No.
But that's probably not the best image to use to
I agree.
try and show anything either way.
Yeah.
Here, let's put a line across that just because.
That's a waste of time.
Now I think it's interesting how even though the balloon went higher, the line got straighter.
As I said in my demo with the ball, it depends what aspect of the curve you take an image of and then scrunch as to how curved it looks. Okay? You're putting a straight
Now
line
let's try
there.
this again with
You're
the
putting a
highest
straight
altitude.
You're putting a straight line there along an image that you've already manipulated, so that's not a fair test anyway.
So it seems like he is saying, as long as it's curved, it's a fair test. But so long as it's flat, or even halfway flat, he either doesn't want to acknowledge it, or he claims it was an unfair test.
No, like the image behind me, just there, you put the yellow line against the original image and then scrunched it, and you can see that there is definite curve against that yellow line. Having scrunched it, like the third image, you know, across, the one that says flat at 25,000, you scrunched it. Now if you put a line across that, where it does look reasonably flat because of the angle of the curve and the camera, and before you scrunched it, then you're putting a flat line against a distorted image. That's not the way to prove anything or show anything.
Excluding the first image here at 3,000 meters, of course.
What, the one that actually shows a nice curve above your yellow line? That's not a fair test anyway.
Of just over 37,000 meters and see what we get.
That's more like it.
Okay, go adjust that brightness and contrast. And we got a blip there. Looks like it's coming from the lens flare.
Yep, lens flare, definitely, I agree. Now, just ballparking that by eye, can you not see the curve?
Alright, let's do the scrunched horizon part.
It looks curved to me.
Scrunch. Zoom in on that. Now I do see some curvature.
I am honestly really, really glad that you've acknowledged that throughout.
So am I.
That is excellent.
Yes.
But the question is that the curvature of the Earth that we are looking at?
Well, if you had drawn a straight line using your graphics package before you did your scrunch, you'd have seen that your straight line was still scrunched, but the horizon, the curve was accentuated. That's the whole point of taking a straight line on the image and then doing the scrunch, okay? Well, you would have to posit an alternative explanation. we're photoing the Earth, or videoing the Earth. We can see the Earth. The Earth looks curved in the image. Therefore, without an alternative explanation, I would say that's because the Earth is a sphere. The only other possibility that I'm aware of is distortion, but we have ruled that out by using imagery across the sweet spot, as you so aptly put it, across the centre of the screen. We've also got the reference line strings. If the Earth is being distorted, the strings would be distorted.
Good point.
And this does not correlate with any bending in the strings. So therefore, without an alternative explanation at this point, I would say, yeah, it's the curve of the Earth.
You've convinced me.
Man, if that is the curve of the Earth seems to be continually changing shape, flopping around like a floppy pancake in the air.
No, it's because each one of those images is with a camera pointing at a different height at the horizon and a different angle, and then when it's scrunched, you're going to get a different curve. But you're still going to get a curve.
Alright, so if this were the curvature of a globe Earth that we are looking at, I would expect to see the horizon start out looking relatively flat and then gradually become more and more curved the higher we rose in elevation.
Well, even at the highest elevation, the amount of curve is only going to be a few degrees off of straight. So seeing the difference between the low altitudes and the high altitudes is going to be very hard. And of course, the lower the altitude, the more difficulty you're going to get because of cloud and atmospheric effects.
And I would expect to see even amounts of curvature throughout each photo.
Where did Mr. S go?
But here I'm seeing all kinds of inconsistent curvature. If that were the curvature of a globe Earth, the Earth would be rapidly changing shape, and I would think we would notice that on the ground if that were the case. Now, Mr. Sensible also mentioned the other possibility of lens distortion here. If it were lens distortion, I would expect to see a pretty consistent amount of curvature in each photo.
Well, if you were taking the image with the horizon across the same part of the viewfinder, then any distortions would be consistent, yes. But as you can see, each one of those images, the horizon's higher or lower and at a different angle, so you're going to get any different distortion. However, I do not say that it's distortion, but that was a possibility.
The horizon should not have appeared flat at 3,000 meters, nor should it have appeared flat at 25,000 meters. Mr. Sensible is pretty insistent that it is either the curvature of the Earth or it is lens distortion. I'll entertain those two options for another moment here. We aren't exactly looking at solid ground here.
No.
We are looking at clouds, and clouds are very much known for changing shape.
Well, they are, but of course the higher up you get, the more homogeneous a horizon you're going to get, because any lumps and bumps and dips and missing bits of cloud is all going to even out.
That could explain why we are seeing varying amounts of curvature in each photo. On the other hand, with our other option being lens distortion, I have to wonder if we have an autofocus going on here.
Well, with the lens distortion, you can see those two reference lines. They do not change from the very first image when I'm holding holding MAGE looking at me, right throughout the flight, all the way up, all the way down, until when it lands on the ground upside down. Those two strings appear exactly the same.
Mr. Sensible did mention that some images were blurrier than others.
Well, yeah, because looking at that image you got on screen above me now, that's a low image looking across just the tops of clouds, so you've got sort of a misty horizon. It's nothing to do with the focus changing.
Maybe that is because the shape of the lens is changing.
What? The shape of the lens?
But what about the two straight lines? Why aren't they distorted?
Good. So you've noticed that, well, they are distorted. I don't know if you can see that black line just across the top of my head. There is a slight dip. With the lighter coloured line, there is a slight curve the other way. a lot slighter, just because that happens to be slightly closer to the centre of the viewfinder than the centre of the lens than the lower screen.
Are they physical strings that are taped across the camera lens?
Yes, Kyle. They're physical strings, okay? They're not taped across. They're about half a metre, bit less than half a metre away from the camera lens. But they're physical strings. You should have watched MAGE experimental video a bit more closely.
Or are they just digital lines on the HUD, like the meter on the right here?
No.
Sorry, it's a MAGE thing. When he named his project MAGE, that got me looking for some kind of Carbonaro effect. I'm doing my analysis based on the inclination that he is being sincere.
Well, I've just shown you those are strings, and I am 100% sincere, 100% honest.
But the possibility of him doing a sleight of hand still weighs on me in the back of my mind somewhere.
Well, Carl, to be fair, I have done nothing explicit to make you think I've done anything underhand. You've not caught me out. I know we disagree about things, but you've not caught me out in any lies or anything, and nobody else has either. So I always operate on the basis that people I'm dealing with are dealing honestly until some evidence shows me otherwise. And you have been treating me that, although with this bit of a proviso, until I have actually shown something that, or until I've actually done something that shows dishonesty, yeah, you should carry on to treat me as honest.
But on closer observation of the two lines, I do see shadows on the top line here.
Yes.
As well as the sun lighting it up from time to time. So that gives me some confidence that it is an actual string, and inclines me to believe that he is not just pulling my...
I'm not pulling your anything. And yes, that's absolutely right. You can see the light and shadow, and as I showed you, the actual strings. So that's great. So now you know I was being honest about that.
my leg here. With that being said, I lean towards the first option, that these effects are not caused by camera distortion, but that these are actual effects on the horizon that we are observing.
Yes, well, that means we agree. Camera distortion comes into it in that if your horizon line is not across the centre, you're going to get a little bit of barrel distortion, but then you can compare that slightly distorted area of the image with the reference line strings. While we're across the middle and we've basically not got distortion, then it's something else. And as you've acknowledged, it appears to be a genuine effect.
Now, Mr. Sensible has some more commentary, so I'll let him continue with that.
Oh.
Let's compare Mr. Sensible's footage with this picture of the Earth supposedly taken from space.
I can see my house from up here.
Here I'm selecting the photo. Now please notice how, as I rotate the photo, the center of the curve always remains about the center of the curve.
Yes, you have taken the centre of a circle. I mean, I don't know what is quite so impressive with that. If you take the centre of a circle and rotate that circle, then the edge of that circle will always be equidistant from that centre point. That's basic geometry, Kyle. Yeah, and why? Because you have the centre point of that circle. I just said that. So yeah, the edge is equidistant from that centre point, so it's always going to be a smooth rotate. You're just copying what I said, cheeky monkey. Now if you took and rotated about that point there, it's not going to, you're not going to have the same effect, are you?
No.
You're going to get a circle that swings around like that. Remember that. So I'm not quite sure what you think you're showing there. And of course, with this photo, you're able to actually locate the centre of the diameter of that Earth. On my imagery, you're right up close to one edge. You have no hope of finding the centre point to rotate around.
All right, let's move that anchor point and test out what he said.
Right, so Kyle is now responding to that comment I made, and that anchor point that you've got is now nowhere near the centre. Remember what I said, Kyle, if you're not near the centre, if you're close to the edge, you're going to get the image turn like that rather than rotating smoothly around that centre. Let's see what happens.
Right here, the center of the curve.
That's not the centre of the curve though, is it?
Appears to be the center of the screen here. Now I'm going to rotate that.
Bingo. I mean, I know this is, to be honest, Carl, almost embarrassingly obvious what I said. Because you're near the edge, the whole image, the whole Earth is tilting. It's not smoothly rotating around. That's not rocket science. Did I really say that?
The center of the curve still seems to be about the center here.
That anchor point you placed, let's say, 1 centimetre away from the edge of the image, because you've rotated it, is not going to change how far from the centre of the image it is by rotating the picture. That horizon line is always going to appear that distance from the anchor point.
Let's rotate it the other way. Oops. Rotating it the other way.
What are you hoping to show here?
The center still seems like the center.
Kyle, I really don't wish to be rude at all, because we've both been respectful to each other, but this aspect of your video is just some sort of failure of understanding. It's got to be. I don't know what else you think you can, what else you think you're showing.
Nothing's changed. What I'm saying here is, with that apparent picture of the globe, we don't get any kind of this weird lopsidedness going on.
Because that is a scrunched and distorted image. You have changed as a smooth, curved line. You've changed it. You've bent it more on one side than the other because the curve was at an angle.
All right, now we're going to do the scrunched horizon thing.
Aha.
Scrunch! Now as we zoom in on this, please notice how there is even amounts of curvature on the left and on the right.
Yes, there is. Down here, this curve mirrors this curve. However, the curvature shown here is different than the curvature shown there. Which is what I'm saying, Kyle. Depending where around that curve you're looking, when you scrunch it, you're going to get a different amount of distortion. Once you've distorted it, it's no longer a smooth curve. You have changed it. You have distorted it. So all you can use that image for is to prove that the original object was not a straight line. In this case, we've done it. We've proved it by accentuating the curve of the Earth, making that really sharp hump. But it's a different amount of curvature depending on which part of that circle you're looking at. It depends on the angle. Here, the surface of the Earth is close to vertical, so it's just being pushed to the left. Here, the surface of the Earth is close to horizontal. Are you getting paid for this? Because I think I should get your money. And so it's getting more distorted. You've just shown why you can't use the amount of curvature in a scrunched photo to prove anything other than that surface was not straight in the first place, i.e. you have accentuated the curve. Remember, in that photo you scrunched up that had the yellow line remained straight. It did not curve to any extent whatsoever.
Yes, I acknowledge that when I scrunched the photo, I changed it from a circular image to an elliptical one.
Boom. And once again, Carl, thank you. Thank you very much for the acknowledgement.
Therein, after scrunching the image, I wasn't looking for equal amounts of curvature throughout the entire photo anymore. I was looking for this mirror effect. I expected to see the peak of the curve in the center of the screen.
But the image you scrunched was the whole Earth. If you zoomed in on part of that curve, a bit where it's, say, like that, and scrunched it, you are not, of course, going to get that peak. It's only because you had the entire curve that you've ended up with a nice peak and mirror. Take a quarter of that image, do it again, and you will find you do not get a nice peak.
And I expected to see the left side mirror the right side. But my observations are not consistent with my expectations of what things should look like on a globe.
Well, observations not meeting expectations is fine. You then either need to explain why they don't meet your expectations, or you adjust your expectations based on the evidence.
And that is why I have a problem with believing the claim that we are looking at the curvature of the Earth here. I shared our globe picture here as a standard to judge our other photos off of. If the other photos were of a globe, I would expect similar results.
Oh, thank you, Kyle. Put your world to the test. Yeah, thank you, Kyle, for tackling my video. I really appreciate it.
I did.
Obviously, I think you're wrong. I know you're wrong.
That's right.
I'm going to show you why with regard to those scrunch curves in just a second.
And I did.
But that was a decent attempt at a debunk.
It was, and I will reiterate that. In my dealings with Kyle, he's always been polite and respectful, and I've tried to be exactly the same back to you, Kyle. Although I I do like teasing and poking a bit of fun, but honestly, I do respect that how you've handled yourself in this. Thank you.
So, cheers. Right, let's have a look at a load of balls.
Like that.
So here's a size 5 Dunlop basketball that some kids have lobbed into my garden.
No, Kyle, this is where I take images from various parts of that ball, so we end up with different amounts of curvature in the image before scrunching, and see if we get that mirrored effect. We know that that is a ball. We know that it appears as a circular object.
Let's scrunch it. There we are. An image that pretty much equates with your image of the Earth taken from space.
Nice mirrored
Excellent.
curve. Yep.
Now let's have a close-up, just part of the horizon.
This is where it gets important, because in effect this is the sort of view, accentuated, but this is a sort of view you get from MAGE. You don't see a full half of the curve, so you cannot get a nice mirrored curve with a hump in the middle, and then you also have to allow for the fact that the camera is tilted one way or the other all the time.
And scrunch that as well. And we'll do yet another one and scrunch that. Now what have we got? Well, this was just quick and dirty, but you see, you get very different curves depending on the angle that the curve is crossing your field of view.
Just like those scrunched images you took from the MAGE video. Different parts of the curve scrunch up differently. So this was my demonstration explanation of the effect that you had found and were concerned over. We'll see how you responded to this.
You can try it yourself, just get a ball and take numerous photographs and scrunch them. It's quite obvious really. So there we go, Kyle. It depends which part of the sphere is crossing the screen when you scrunch it down as to how that curve appears.
You really are oh, he's gone. He's running away. You really are a rip-off merchant, aren't you? Everything I said you're saying.
Alright, so taking a look at this ball, I can see that the peak of the curve is in the center of the curve, and that the right side of the curve appears to mirror the left side with equal amounts of curvature.
Good.
Alright, so let's go ahead and scrunch that real quick and check it out. Huh. Zoom in. Alright, now let's go ahead and level that out here. Interesting.
You're not Jaren, isn't
Now
it?
the ball appears to have uneven amounts of curvature on both sides, and it appears lopsided.
So now we're interested in what you're going to say about it, Kyle?
That very much reminds me of this image here at 11,000 meters.
Doesn't it just?
I can't say I was aware of this observation when I made my first video. So I'm totally learning something new here. And science is all about learning, so this is a good thing.
Yes, it is. Because it's not a case of I told you so. It really isn't. You did have a misunderstanding about how it works. That's okay to misunderstand something. I've given a demonstration to explain it to you. You have looked at my demonstration explanation, You have taken it further by doing some further tests. You have acknowledged that you were wrong about the way the scrunched images work, and you've moved on from that. Absolutely 10 out of 10, Kyle. I give you big kudos for that. That's amazing, and you're right. It is about learning stuff, and I am more than happy to learn something too if I come across something that's evidence. So honestly, I am over the moon. I'm sure that we still don't agree on everything, but I'm happy, more than happy, to say well done, thank you, and that's not meant in any patronising way at all. Well done and thank you. You have shown the right way to behave, which is when evidence shows that you're incorrect, you accept the evidence, you learn, and you move on. Brilliant, absolutely brilliant, and thank you, Kyle.
Now, with this ball representing a control in the experiment, I've got to say that my expectations have changed concerning what should happen if I were to scrunch an image of a globe. With that being so, our picture taken from 11,000 meters now checks out with our control.
Fantastic. I'm over the moon, Kyle. I genuinely am.
But what about our half-curved image at 15,000 meters? And our flat image at 25,000 meters?
Well, you're going to have to take different images of the ball to try and mimic the position and angle of the camera, and then scrunch and then do your comparison. It will be the case, but it's going to be tough to find the exact same sort of curve to make the same scrunch effect.
Do those check out with our control? I don't think so.
Well, have you tried? Don't let us down now, Kyle.
You're going to have a hard time trying to convince me that those were caused by tilting the camera in a special way.
Well, now this is where I am a little disappointed, Kyle, because you've acknowledged, quite rightly, that lopsided curve, which matched one of the curved images I took of that ball. So you should take the next step. Take a ball, take numerous photos of it at various angles, see if you can get nearly flats and curved, half curved, like those images we got just here. That would be testing out, trying to test this new curved scrunch theory. Maybe you could debunk it, or maybe if you tried it, you'd find that you could get matches for each of those. So, yeah, 10 out of 10 for your initial acknowledgement and saying that you've learnt something, but minus several million, Kyle, for then just hand-waving the rest of it away without trying it yourself. Sorry.
Please note, I still have the expectation that if it were the curvature of the Earth that we were looking at, it should start out looking relatively flat and then gradually appear more and more curved the higher we rose in altitude.
Well, yes it does, but the difference is absolutely minimal, and with scrunching you override any visual difference just to determine that the horizon, like in each of these, is not flat because the scrunch has accentuated the curve.
But that isn't what we observed, so I can't conclude that the curvature that I acknowledge that we are observing is caused by the curvature of the globe Earth. Now again, to be very clear, I don't think the curvature here is caused by lens distortion.
Good.
I believe these are actual curves that we are seeing in reality.
Brilliant. So then the only thing we've got to determine is that because the Earth is curved, or is the curve there because of something else?
However, I'm still not convinced that we are seeing the curvature here because the Earth is a globe. So here's the question. If we're not seeing curvature from a globe, what is causing the curvature?
Absolutely. That is the question.
Here is my hypothesis and my flat Earth model prediction.
Mm-hmm.
My hypothesis is that the curvature we observed in the MAGE footage was not being caused by the Earth being a globe, but instead it is being caused by the sun's radial light reflecting off the cloud tops.
But then you would get a different amount of curve depending which direction you're pointing, whether the sun's to the left, right, in front, or behind you. And I don't believe that's the case.
Now I'm going to put that hypothesis to the test.
Good. I wish you'd have put the ball scrunching hypothesis to the test as well, but never mind. Let's see what you got.
Get ready for this. Please keep this in mind while I'm at it. I think my hypothesis does a much better job at explaining how we're seeing inconsistent amounts of curvature here in each photo. Let's take another look at that curved horizon at 11,000 meters that just barely checked out with our control image. Here we are, 11,000 meters, unaltered, straight from Mr. Sensible's video.
And before you go further with it, we can see, looking at the wide cam above, the sun is directly behind us. Okay.
All right, let's put an arrow at where we think that horizon is. Right here, right?
Maybe.
All right, let's go ahead and change the brightness and contrast and see what happens. It went up. Look at that.
Right. I'm going to say I don't think that that's a fair thing to do, but I don't want you just to turn around and say, well, you can't claim that about every thing I say. What I would say is when you're making adjustments to brightness and contrast, you're adjusting pixels up or down in brightness based on their current value. Where we have made these adjustments before, it's not to determine the exact position of a horizon, but it's to determine that it's not a straight line. I'll let you run on with this and we'll see where we get to.
Whoa! It's really going up there now.
Well, you've just overexposed an image. If you took a picture of my beautiful face and then overexposed the image, exactly the same sort of thing will happen. But it doesn't mean I haven't got a beautiful face with a lovely curved dome.
Think I can get to go black and white from way up there? Oh, look at that. That horizon is moving all over the place.
No, what you're doing is you're making adjustments so that smaller and smaller variations in brightness are picked up and then accentuated.
Why is that happening? Still, the horizon looks like it's up there, right? What's going on is it's that light reflecting off of the clouds.
Well, it's not clouds. I mean, there is stuff up there, molecules of air and maybe some moisture, although it's pretty dry up there. So there is stuff. I mean, you're actually only at what height on this one? I forget, 11,000 meters. So that, yes, there is air above you and probably a certain amount of cloud. You go higher, though. Go up to sort of 37,000 meters, or whatever it was, where there are no clouds above you and the sky is black because there's nothing for the light to reflect off and refract around and so on.
Please also notice here how this horizon appears generally flat.
Well, like I said, you're quite low, but carry on. Do this with a high height image.
But all of a sudden, as we change that brightness and contrast and raise it up, all of a sudden now it's looking curved. All right, so that's two confirming evidences. Now here's a third. Please watch how, as I adjust the brightness and contrast, not only do we see a curve up here, but we also see a curve down here.
Whoa. Right. You're looking at the shapes of clouds there. You can see just here a dark area. Was that thin cloud? Was it a bare patch of sky? That's not going to be the curve of the horizon, is it? Whether the Earth is flat or spherical, we want to be looking up there a bit towards the furthest distance you can see to try and see what the edge looks like, the edge of the visible Earth. You're looking at stuff here. You're just looking at, as I said, a thin bit of cloud or a lack of cloud in some way in that area.
You see that? Here's that curve right down there. Make it really clear all of a sudden. Yeah, you can definitely see that curve.
I'm going to, at the end, very briefly, do the same sort of thing with a photograph of me.
And the whole reason why we're getting that
is image processing,
is because
CGI.
of the sun's reflection off the cloud tops. So that is 3 confirming evidences that the curvature that we saw was not caused by the Earth being a globe. That also explains how you can see curved horizons on a flat Earth. And that, my friend, is what science with an emphasis in art looks like. A special thanks to Mr. Sensible. You've brought some new things to my attention that are going to require me to go back and rewrite some of the curriculum in the Flat Earth Institute of Science. So thank you for that. And thank you all for watching.
Well, as I said earlier, big thanks, Kyle, for your video responses. Massive thanks and acknowledgement for moving your position based on what I showed you. I don't think that you provided an alternative hypothesis about the light and a couple of evidences to help support it. I think I would say it's not enough, but at least you have put forward something. So let's take this image. We got this lovely, beautiful curve, this dome of the top of my head, and over here on the chair back, we got the shadow. Now that's a fairer thing to look at because that's like the clouds. It's not a sharp delineated edge, it's a bit fuzzy. So let's now change some of the adjustments like you were. So if we change exposure up and down, look at the shadow on the chair. So if you look at it just here where it is there and watch as I adjust this, it moves. Look at that bright area, it's moved down. We've changed the shape of it until it's all gone. You can tinker with this. All it's doing is it's running an algorithm across the data of the image. There we go, look at that fading away and the black area is getting bigger and bigger. All it's doing is it's running an algorithm across the values of the data, and if it's a certain value it'll knock it up a bit, or a certain value it will knock it down a bit. You're not actually changing the shape of that shadow or my head. You're just adjusting and picking up various levels of graded light or shadow. So it's nothing to do with the sun bouncing off the clouds. There's not really much more to say about that, Kyle, because changing those values doesn't change the underlying shape, and the whole point is that shape is a curve. So massive thanks, Kyle. Now I added you to the worthy attempts list, and you genuinely deserve that. We obviously don't agree about everything. I haven't persuaded you of the globe Earth. However, you have shown the decency and honesty and openness in admitting that you were wrong about something and then adjusting your position. I salute you for that, I genuinely do. I look forward to seeing you all again soon. Until next time, stay sensible.
Shut up and sit down.